Number 9, what we have to do is we have to write down a 8051C program to toggle bit number P2.4 continuously without disturbing the other remaining bits. So here what we have to do is we have to toggle only P2.4, means port number 2 and line number 4, and the rest of the bits will be in ideal conditions. So we don't have to disturb other bits. So here what we have to do is we have to use a single bit variable connected to line number 2.4. LED is single LED is connected to line number 2.4. So this LED will be on and off. So that is called as a toggling. So after writing a program and executing a program, this P2.4 should be continuously on and off. You can see that it's a standard format. We have RGX 51.h that is included, and here the main part that we have to look at is S bit my bit is equal to P2 cap 4. As I told you earlier, if it is a port number 2 and line number 4, it is distinguished by point in a return letter, whereas in a compiler it is written in a cap. So it is port number 2 and line number 4, and we have to declare this single bit variable before the void main void. And after the void main void, what we have is for, and this for is in a forever loop or it is in a super loop. So at the first we are giving my bit is equal to 0, and in the second line we are saying that my bit is equal to 0. So whenever the my bit is equal to 0, the LED will be off, and whenever the my bit is equal to 1, the LED will be on, and this loop will be executed forever. Going to add, here we are going to add existing file, and here you can see that we are going to add assignment number 5. So sorry, it's assignment number 9. Add it and close it. So if I double click it, here you can see that the program. So here this is the main part. S bit my bit is equal to P2 cap 4. So here you can see that it is port number 2 and the line number 4, and this is a for loop in which we don't have any initialization condition, whether we don't have any check condition, and we don't have any increment condition. So in this case it will be used as a forever loop. So let us compile this program first. So I'll compile, and here you can see that we don't have any error or the warnings. Now we can simulate this program by clicking on debug, start stop debug session. Okay, and here I'll close this port. I think we require only a port number 2, so I can go with the peripherals, IO ports, and now I'll choose a port number 2. So let us execute this program step by step. So I'll click on this. So by clicking on this, you can see that port number 2, line number 4 is on and off continuously. So this is stepwise execution. You can have a continuous run by clicking on this button. So here you can see that it's a continuously on and off. As it is a persistence of vision, there is no delay. So that is why we cannot see it by continuously running. We can see it manually. Okay, now I'll reset this controller and I'll come out of this debug session. So this was assignment number 9. So in assignment number 10, what we have to do is we have to write down a 8051C program to monitor 2.5, and if it is in high status, that is logic 1, then we have to send a 55H to port 1, and otherwise what we have to send is AA to port 1. So here there are 3 things that we have to look at. One thing is that we have to monitor 2.5, so it is a single bit variable. The data that we want to send is an 8-bit data, and there is a if and else kind of a statement. So if the 2.5 is 1, then we have to send 55H, else we have to send a AA to port 1. We have connected one switch. Now this switch has 2 states, either on or off, and according to that the LEDs those are connected to the port 1 will be receive the data, that is 55H and AAH. So if you can imagine, 55H means alternate LEDs will be on and off, and AA means also the same thing, the alternate LEDs will be on and off, like 0101 and 1010. So just we are toggling a port. Number 10, as I told you before, whenever we are using an sbit variable, it has to be declared before void main void, and this sbit data type is used when we are interfacing any single bit variable externally. So here we have an sbit variable which name is mybit, and it is assigned with port number 2 and line number 5. Now here, after that, we have to write down void main void, and here after that, what I have written is my bit is equal to 1. As you know that by default, all the ports of an 8051 are output port. So to make that particular line as an input line, we have to assign it to as a 1. So when I assign this value as 1, it will configure that my bit, and that is nothing but the port 2.5 as an input port line. After that, what we have to do is here within a forever loop we have if loop, that is if my bit is equal to 1, then port 1 will be assigned as 0x55, else it will be assigned as p1 is equal to 0xaa. So 0x55 means 0101 and 0xaa means 1010. So depending on whether the switch is on and off, according to that the pattern will be sent. So whenever the switch is on, 55 will be sent, and whenever the switch is off, AA will be sent to the particular port, and that is port number 1. Vision 5, in a microvision 5, I have already given you the source file, so just you add that particular file. So it's assignment number 10, add and close. So if you double click on this, you can look at the code. So whenever you load the code, first of all you have to compile this code. So after compilation, you have to look at 0 error and 0 warning, and then only you will be able to execute this program. Now let us simulate this program to understand the logic behind this program. So I'll go to debug, start stop debug session, and I think I have to make some changes within the program. I'll go and I'll stop this debug session. Even you can learn. Well, I have made one mistake, that is I should send it to the port 1. So I should mention port 1 over here and a port 1 over here, and I am sending AA, right? So that the connection. My beat, it is monitoring 2.5, that is another correction. So we are going to monitor 2.5. After that, my beat is equal to 1, so I'm making this line as an input line, and this is a forever loop, and whenever the bit is 1 we are going to send 55, and whenever the bit is 0 we are going to send 0xa. So it looks perfect. Now let us simulate this program. Well, before that we have to save it, and again we have to compile it because we have made some changes in this. So again we are getting 0 error and 0 warning. Now we are ready to simulate. So start stop debug session, okay, and here we have to monitor 2.5, so let it be there, and the output that we are looking at port 1, so we are going to add port 1. So this is my port 1, this is my port 2. So this port 2 is acting as an input, and whereas the port 1 will be acting as the output. So the bits will be toggled. Now here by default you can see that all the tick marks are there. It means that it has a logic 1. So if it is a logic 1, so let us see that we should get a 55 at port 1, and let us run this stepwise. So I'll run this program. So it will go to the my bit, and here you can see that it will assign 55 to the port 1. So this looks perfect. Now let us run this program once again. Okay, so as you can see that bit status is 1, and that is why it is sending only 55. Now we will change this bit and we'll make this bit as a 0. So we are looking at P2.5. So here is P2.5. So I'll make it 0. And now let us check the output. Now here you should send 1010. So as you can see that now it is sending 1010. That is nothing but a. So this is how you can use if-else statement. This is how you can use the if-else statement. So here we'll stop. I'll reset this and I'll stop this debug session. So this was assignment number 10.